Welcome to the DIY Honda Garage channel. DTC P0967 stands for CVT-driven pulley pressure control valve circuit high. This critical diagnostic trouble code indicates a specific electrical circuit issue that arises within the continuously variable transmission CVT system of the Honda CRV produced between 2017 and 2022. The CVT-driven pulley pressure control valve plays a vital role in regulating the hydraulic pressure for the CVT. It is typically located within the transmission assembly, near the valve body, which houses various hydraulic controls essential for transmission operation. This code cannot be attributed to any mechanical failures in the transmission itself. It strictly highlights an electrical aspect. Proper troubleshooting is crucial, as ignoring this DTC could lead to shifting issues or further transmission damage. The DTC P0967 pertains directly to the CVT-driven pulley pressure control valve circuit, which governs the hydraulic pressure necessary for the effective operation of the CVT. This valve is strategically located within the transmission assembly, specifically adjacent to the valve body area, which houses various control mechanisms. The importance of this component cannot be underestimated, as it directly influences shifts and overall vehicle performance. Should the valve or its circuit fail, it compromises the hydraulic pressure, potentially leading to erratic shifting behavior, reduced fuel efficiency, and increased wear on transmission components. Since the code identifies a circuit high condition, it is crucial to focus on the electrical connections and ensure the integrity of the wiring harnesses and connections to the powertrain control module, PCM. The PCM monitors signals from the valve and adjusts hydraulic pressure accordingly, linking back to the importance of ensuring the electronic aspect is functioning correctly. Several potential causes may lead to the emergence of DTC P0967. Firstly, the primary concern revolves around electrical circuit problems within the vehicle's wiring, which can arise from fraying, corrosion, or general wear over time. Poor connections or loose terminals between the CVT-driven pulley pressure control solenoid valve and the PCM can exacerbate problems, leading to inconsistent signals that trigger the warning. Another cause could be a malfunctioning solenoid valve, which fails to operate effectively even if the wiring is intact. Furthermore, shorts in the wiring may create erratic electrical flow, revealing that shorts to power can exert undue pressure on the system. Proper diagnostics and troubleshooting procedures will help pinpoint the underlying issue, ensuring a successful resolution. Understanding the symptoms associated with a DTC P0967 is essential for early detection and prevention of further damage. Drivers may experience erratic shifting behavior due to the improper control of hydraulic pressure within the CVT. This erratic shifting not only makes the vehicle feel less responsive, but can also lead to additional strain on the transmission components. Transmission overheating is another potential symptom, as improper hydraulic control can lead to elevated operating temperatures. Along with these, lower fuel efficiency might be noticeable, since the vehicle's transmission struggles to maintain optimal performance. Lastly, an illuminated check engine light typically serves as a driver's warning that there's a malfunction within the engine or transmission control systems. Recognizing and addressing these symptoms promptly is vital for maintaining vehicle performance and reliability. For the first troubleshooting step for DTC P0967, it is essential to ensure that the vehicle is powered on. Start by turning the vehicle's ignition to the on mode without starting the engine. Then, clear the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This process is crucial, as it resets any stored error codes, which allows for an accurate fresh start in diagnosing the issue. After clearing the codes, you will need to start the engine and allow it to run for at least 1 second to ensure that the system can register and identify any current or pending DTCs. Finally, check for any pending or confirmed DTCs through the HDS again. If DTC P0967 appears as a confirmed DTC, the failure is duplicated and you will proceed to step 2. If it shows that the system is okay, then it may indicate an intermittent failure where further inspection of electrical connections may be necessary. Step 2 of the troubleshooting process involves checking the CVT-driven pulley pressure control solenoid valve. Start by turning the vehicle off to ensure safety while working with the electrical components. Next, utilize the HDS to jump the SCS line, service check socket, to protect the PCM during testing. Wait for over 1 minute to allow the system to stabilize. After this step, disconnect the PCM connector C, specifically the 51P connector. Now, it's essential to measure the resistance between specified test points. With the vehicle in the off mode, you're looking to measure resistance between the number 10 terminal of connector C and the body ground. Ideally, this resistance should range between 5.0 and 6.3 ohms. A reading within this range indicates that the CVT-driven pulley pressure control solenoid valve is functioning correctly. If the resistance is within the expected range, you will next need to consult any additional service information associated with DTCs or symptoms before considering a replacement of the PCM. If not, proceed to step 3. The third troubleshooting step focuses on checking for any shorted wiring, particularly in the DNLS line leading to power. Begin by disconnecting the solenoid wire harness A, 8P connector to isolate the circuit. After disconnection, turn the vehicle to the on mode without starting the engine. With the vehicle in this state, measure the voltage between specified test points, which includes the number 10 terminal of the PCM connector C and body ground. It's essential to determine the presence of voltage in this configuration. The expected results are a voltage reading, which would indicate a short to power condition in the DNLS wire. A voltage presence here suggests wiring issues leading to a short circuit, necessitating repair. Should there be no voltage detected, this implies that the DNLS wire is not shorted to power, leading you to step 4 for further investigation. In step 4, the focus shifts to checking for an open wiring condition within the DNLS line. Begin by ensuring the vehicle is turned off to safely inspect the circuit. With the vehicle in the off mode, check for continuity between 2 designated test points: the female terminal number 3 of the solenoid wire harness A8P connector and the number 10 terminal of the PCM connector C. Confirming continuity is crucial, as a successful continuity test indicates that the wiring is intact and functional. If continuity is confirmed, it suggests that the system is otherwise healthy, allowing you to move forward to assess the next components in step 5. However, if continuity is not present, it indicates an open in the DNLS wire that will need repairing before proceeding any further. Step 5 allows us to dig deeper by checking the continuity of ground lines, specifically GND1 and GND2. Ensure that the vehicle remains in the off mode during this procedure. Disconnect both connectors B and C of the PCM to isolate the grounds fully. The next task is to measure continuity between PCM connector B terminals and body ground. By doing this, you're assessing whether there are any interruptions along the ground path. A successful continuity test reveals that the grounding between the PCM and the body is functional. If continuity fails, it points to either an open in GND1 or GND2 wires that should be repaired immediately. Additionally, a poor body ground at G101 could also be the cause and should be examined and rectified to ensure a solid ground connection throughout the electrical system. For the sixth troubleshooting step, focus on the CVT-driven pulley pressure control solenoid valve's internal resistance. Start by disconnecting the 2P connector from the solenoid valve to isolate it for testing. It's imperative that the vehicle remains in the off mode during this check. Measure the resistance between the specified test points on the connector, between the male terminals number 1 and number 2. The expected resistance for a functional valve should measure between 5.0 and 6.3 ohms. If the reading falls within this range, proceed to step 7, as this indicates that the solenoid valve is functioning optimally. Conversely, if the resistance falls outside this acceptable range, it points to a faulty CVT-driven pulley pressure control solenoid valve, warranting the replacement of the entire valve body assembly to restore proper transmission functions. The seventh troubleshooting step delves into checking for continuity in the DNC line. This step requires isolating the system by keeping various connectors disconnected, particularly the CVT-driven pulley pressure control solenoid valve's 2P connector. With the vehicle in the off mode, measure the continuity between the female terminals of the solenoid connector and body ground. Achieving continuity confirms that the DNC wire is intact, signifying a good connection between the solenoid and ground. If continuity is not present, there could be an open in the DNC wire that needs repair. Additionally, inspecting the condition of body ground G161 is vital here, as poor connections can lead to malfunctions in your solenoid operation, emphasizing the essential nature of good grounding in electrical systems. In the eighth and final troubleshooting step, the focus is on determining continuity in the DNC Plus line. You will need to disconnect solenoid wire harness B, specifically the 6P connector, to clearly assess the integrity of the wiring. With both solenoid harness A and solenoid harness B disconnected, measure continuity between the designated terminals of harness B and the corresponding terminals in the CVT-driven pulley pressure control solenoid valve. If continuity is confirmed, this indicates that the wiring between solenoid harness A and solenoid harness B is intact and must be repaired. If no continuity exists, it signals that the wire running from the CVT solenoid valve to harness B needs attention. Ensuring that all connections are sound promotes the proper functioning of the electrical circuits essential for smooth transmission performance. Once all identified repairs have been completed, conducting a final verification is crucial to ensure that the repairs have effectively resolved the issue signified by DTC P0967. Begin by using the Honda Diagnostic System, HDS, to clear any diagnostic trouble codes that may still be stored in the system. After clearing, proceed to conduct a test drive of the vehicle under various driving conditions. During this test drive, ensure that the transmission operates smoothly, checking for any signs of erratic shifting or performance issues. A successful outcome includes no reappearance of the DTC and the transmission functioning as intended. This final verification showcases not only the effectiveness of the repairs made, but also the importance of thoroughness in troubleshooting and fixing the issue at hand. To minimize the risk of encountering DTC P0967 or related transmission issues in the future, preventive maintenance is critical. Regularly inspecting the wiring harnesses associated with the CVT can help detect potential fraying or damage before it leads to failure. Ensuring all electrical connections are tight and free from corrosion is equally important, as loose connections can trigger DTCs due to intermittent functionality. Additionally, monitoring fluid levels in the continuously variable transmission is essential to maintain the system's hydraulic performance. Keeping the transmission fluid at the recommended levels and replacing it at prescribed intervals can enhance transmission longevity and efficiency. Engaging in these preventive measures can help secure the robustness of the transmission and prevent future complications. In conclusion, DTC P0967 signifies an electrical issue related to the CVT-driven pulley pressure control valve circuit and not a mechanical failure within the transmission. Understanding that the problem arises from wiring or connectivity rather than transmission mechanics is key to efficient troubleshooting. The comprehensive 8-step troubleshooting process outlined provides a systematic approach to diagnose and rectify the issue effectively. Once all repairs are verified through testing and final checks, making preventive maintenance a routine will greatly reduce the chances of similar issues arising in the future. Solving DTC P0967 not only restores the functionality of the transmission, but also enhances overall vehicle performance and reliability. Please like and subscribe to the channel. See you next time.